In this video, I'm going to talk about KS test in Python. Why do we need a KS test? Let's talk about t-test first. What does t-test do? A t-test is a statistic method used to determine if there is a significant difference between the means of two groups based on a sample of data. Calculating a t-test requires three key data values. First, the difference between the mean value from each data set. The second one is the standard deviation of each group. The third one is number of data values of each group. What are assumptions when conducting a t-test? The first assumption for a t-test is that scale or measurement applied to the data collected follow a continuous or ordinal scale. The second assumption is the data is collected from representative randomly selected portion of the total population. The third and the fourth assumptions are related to the distribution of the data. The third assumption is asking the data should follow a normal distribution. And the fourth assumption is asking the sample size should be large, because a larger sample size means the distribution of the results should approach a normal bell-shaped curve. The fifth assumption is saying a t-test requires the assumption of homoscedasticity. I have another video talking about homoscedasticity and heteroscedasticity in my YouTube channel. You are welcome to watch that video as well. Then, what's the limitations of the t-test? As I mentioned, the test relies on a set of assumptions for it to be interpreted properly and with validity. Among these assumptions, the data must be randomly sampled from the population of interest, and the data variables must follow a normal distribution. Then we have the question: if the data don't follow a normal distribution, then what do you do? Then we can use KS test. What is KS test? The KS test is a nonparametric and distribution-free test. It makes no assumption about the distribution of data. That means it can be any distribution. With the KS test, we can have one sample test. That means we have our sample data and we want to compare it with our known distribution. For example, we want to verify if our sample follows normal distribution. And also, we have KS2 Sample Test. That means we have two sample sets, and then we want to verify if the two sample sets follow the same distribution. In this case, the distribution doesn't have to be a known distribution. It doesn't have to be a normal distribution or other known distribution. It can be any distribution. When we perform KS test, first we'll sort the observation in ascending order. Then we will calculate the cumulative distribution function of observations. Then, for each observation, we will calculate the CDF for the left side, and then we will compute the absolute differences. We check the difference and we will record the maximum difference. And then we will calculate the critical value and use our hypothesis test. We will reject or accept non-hypothesis. So what is our non-hypothesis? The non-hypothesis is the two samples come from same distribution, and the alternative hypothesis is the two samples do not come from same distribution. As I mentioned in my previous slide, we need to decide our critical value as well. So for the hypothesis testing for two samples, we use this formula to calculate the 95% critical value. It is, we have the size of the sample X and also size of the sample Y, and we take the reciprocal of each one, sum those up, take the square root and times 1.36. This is our critical value, and then we will compare our maximum difference with this critical value to do our hypothesis test. What's the advantages and the limitations of KS test? Like I just mentioned, the biggest advantage for KS test is that the test is distribution free, not like t-test. It requires normal distribution. We can use KS test for any distribution, and the statistic used for the test is easy to calculate because we only need to calculate the differences and then get the maximum value. Third, it can be used as the goodness of fit test following regression analysis. And there are no restrictions on sample size. Small samples are acceptable. And tables for critical values are readily available. Then, what are limitations for KS test? In order for the test to work, you must specify the location, scale, and shape parameters. If you don't have those parameters, you need to calculate or estimate those parameters with your sample data. Secondly, it generally can't be used for discrete distributions. Lastly, sensitivity is higher at the center of the distribution and lower at the tails. Now, let's go to Python, see how we can perform KS test. As you know, the KS test is being used to compare distributions. In this video, I'm going to use normal distribution and the Poisson distribution. Let's draw a graph to show those two distributions first. This is normal distribution and this is Poisson distribution. You can see, obviously, they are not same distributions. What I'm going to do in this test, I will create some sample data based on this normal distribution. And then I will take my sample data to compare with this theoretical normal distribution. And also, I'm going to compare my sample data with this Poisson distribution. I think you can get a conclusion that we should expect the sample data will show it follows normal distribution, because I generated all those sample data based on the normal distribution. And it should show the sample data do not follow Poisson distribution. So first, I'm going to generate some random sample data based on the normal distribution, and I will sort them, and then I will calculate this EDF for our sample data. Then I will calculate CDF for the Poisson distribution, and I'm going to draw a graph to show the differences. Of course, we need to calculate the difference between our sample data and the theoretical normal distribution, and we are going to get the maximum value of the difference. After that, I'm going to do the same thing with the Poisson distribution. I will calculate the differences between the sample data and the Poisson distribution and get the maximum value. And finally, I'm going to calculate critical value for our hypothesis test. Because I'm using same number of data points for the two tests, so we should have a same critical value for the hypothesis test. Now let's run the program. From this graph, you can see the EDF of our sample data is very close to the CDF of this normal distribution, but is quite different from the Poisson distribution. If we check the data, this shows the difference between our sample data and the normal distribution. And the maximum difference relative to normal distribution is 0.047 something. And comparing to Poisson distribution, we have those differences, and the maximum difference relative to Poisson distribution is 0.30. And now our critical value at 95% confidence interval is 0.136. You can see the maximum difference relative to normal distribution is much smaller than the critical value, so we can reach the conclusion our sample data came from normal distribution. Meanwhile, you can see the maximum difference relative to Poisson distribution is 0.3. It's much larger than our critical value. So we can say our sample data is not following Poisson distribution. We have our number of data points 200 for this test. What happened if we change the data points to 20? If we run the program, from the graph you can see our sample data is not that close to the normal distribution curve. And if we check the number, you can see the maximum difference relative to normal distribution is 0.2687 something, and the maximum difference relative to Poisson distribution is 0.30278 something, and the critical value now is 0.43. So in this test, it's hard to say our sample data is normal distribution or Poisson distribution. They are all kind of similar. So that is saying, if we have fewer data points, it might give us difficulty to reach our conclusion. If we have 100 data points, we rerun the program. You see now it shows graph very similar with when we had 200 data points. And if you check the maximum difference relative to normal distribution, it is 0.048. And the maximum difference relative to a Poisson distribution is 0.30. And the critical value is 0.19. So we can reach the conclusion our sample data is coming from normal distribution, because the maximum difference relative to normal distribution is much smaller than our critical value, while for the Poisson distribution, the maximum difference is much larger than the critical value. What this tells us? It tells us if we have more data points, we should use them. If you have fewer data points, sometimes you might have difficulty to reach the right conclusion. This is my explanation about when and how to use KS test in Python. Please provide your comments and subscribe to my YouTube channel. Thank you very much for watching.